You read this example number 12.
By applying the brakes, a driver reduced the velocity of his car from 20 meter to 10 meter square second after a distance of 30 meter. Calculate the deceleration of the car.
Okay. If they ask you to calculate, you don't have to worry whether it's deceleration or acceleration, because if it is acceleration, automatically your answer will be a positive A. If it is deceleration, your answer will automatically be a negative A. So you don't have to worry. Only thing you need to worry is when they are given, the acceleration or deceleration is given, then you have to worry whether to put a positive number or negative a positive sign or negative sign in front of the number. Or in this case, don't need to worry, right? So if it is something like this, at first it's 20, and finally it is 10. The distance traveled is 30, right? Something like this. So now, again, we look at all the 5 variables, all the 5 physical quantities. Okay, so I go through one by one. 10 meter per second to 20 meter per second to 10 meter per second. Which one of these 5 is given? V naught, A, what is given?
Initial to final.
Initial and final. Then
and the displacement.
Correct. Displacement also given. Then what they ask you to find?
The deceleration.
Deceleration.
So
right? A. Okay, so this is what you have to find. So I fill up this symbol with numbers. Displacement 30, final velocity 10, initial velocity 20, acceleration don't know. Then I take out the formula. I try to check which of this formula need to use
the third one,
this.
because we don't have time.
Oh, correct. Very good. Okay, third one, because don't have the time, really your third one. Okay, so now the final velocity is 10, right? So we replace with 10. Initial velocity is 20, replace with 20. Then acceleration, just leave it because you are asked to find acceleration, just leave it like that. The displacement is 30. Okay. Then the 20 square, you move to the other side. So it becomes 100 minus 400. Then 2 times 30 is actually 60A. So you take 300 divided by 60, or negative 300, because 100 minus 400. This negative 300 divided by 60, it is negative 5. So automatically, the negative there tells us that it is deceleration, right? It's deceleration. Okay, so we're going to look at next question, right? Next question. Okay, something like this, right? Number six. You read question number 6.
When a dart is blown from a blowpipe of 1.2 meter length, it travels at a speed of 50 meters per second. Find the time taken for the dart to travel in the barrel.
Okay, so the barrel is something like this. It's hollow, and the length is 1.2 meter. The dart cannot be moving in the first place, right? So at first, the dart is stationary. As it leaves the blowpipe, it has attained a velocity of 15 meter per second. Okay, so this is the question, right? Okay, so we try to check what is given, right? Displacement, is it given or not? When a dart is blown from a blowpipe of 1.2 meter length.
Displacement is given.
Displacement is given.
Acceleration is given.
It travels at a speed of 15. Speed of 15. So this is the initial or final or what? 15
This
meters
is
per second.
the initial. Travels at the speed.
Actually, this is the final velocity. It is initial velocity from the as it leaves the blowpipe. That is the initial velocity. But if it is inside the blowpipe, if it's inside the blowpipe, the initial velocity is 0. The initial velocity is 0. The final velocity is 15. What you are talking about, 15 meters per second, what as it comes out from the blowpipe, if you count from there, then the initial velocity is 15. Then you see how far it travels from the blowpipe, how far it travels. But that is not the case. We are not looking at the dart outside the blowpipe. We are looking at the dart when it is inside the blowpipe, inside the barrel. So if it is inside the barrel, the initial velocity is 0 because the dart at first is not moving until you start to give a blow like that, right? Give it a blow. So it start to move. And as it leaves the barrel, it is 15 meters per second. So the length is 1.2 meter. So the displacement is 1.2 is correct. So this 15 is which one? V naught A or A?
V.
V, correct, is V. Then what is V naught? Is it given? Although it is not mentioned inside the question here, we know the V naught is 0.
Start at a point.
It starts from 0, correct. Okay, so these are the 3 things given, right?
Okay.
Right. So you are asked to find the time.
Find the time.
Find the time. Find this is the time. So which equation?
So we use the fourth.
Very good. It's the fourth one, correct? Right? So you just fill up the numbers, then you see, yes, it is the fourth one, right? Correct. So, okay, we look at the fourth one, right? So delta x is replaced with 1.2. Half, you just write down half. Initial velocity is 0. Final velocity is 15. So 15 divided by 2 is actually 7.5. So you bring the 7.5 over is 1.2 divided by 7.5, 0.16 seconds. Okay, very good. Okay, so now let us look at question number 7. Can you read question number 7?
Daniel drives his car at a constant velocity of 20 meters per second. He steps onto his brakes to reduce the velocity of the car to 10 meters per second after traveling for 30 meters. Calculate the deceleration and the further distance covered before the car stopped.
Okay, right. No, we don't care about the second part. We calculate the deceleration first, the first part. So if you cannot imagine, then you just draw out a certain model, So I just say this is the initial position of the car. Okay, initial position of the car. This is the final position of the car, and it covers a distance of 30 meters here, right? 30 meters. So I just draw a simple model like this, right? Then, okay, right. So we start. Drive a car at a constant velocity of 20 meters per second. Step on the brake, reduce velocity to 10 meters per second. So what are these two given physical quantities? What are they?
They've given the final velocity
Final velocity, correct.
You're given the initial velocity.
Correct. Now, if you cannot, you are not sure whether they are velocity or acceleration, you just look at the unit. Okay. If the unit is per second, is 1 per second, then it is velocity. If it is per second square, then it is acceleration, right? Like in the previous case, it is per second square, right? You are given the, yeah, like this one, right? If you look at this, is second square. Okay, if it's second square, then it is acceleration, right? So you don't have to worry. You can look at the unit and you can recognize whether they are velocity or acceleration. So you are given the final and initial velocity. Okay, then here they say after traveling
They're given the
30
displacement, which
meters,
is 30, and
30,
then they
correct?
want us to find the deceleration. So we will use the
Correct.
third formula.
Yes, correct. So we're going to use the third formula. And before that, you just fill up with numbers first. Yeah. Displacement is 30, final velocity 10, initial velocity 20, and what is the acceleration, right? So we're going to use the third one. This is the third one. So copy down the formula, then fill up with the numbers that you have written down earlier. 10 square equals to 20 square plus 2a times 30. So 100 minus 400, 20 square is 400. Then these two numbers multiplied together is 60. That's why you divide by 60. And you get a negative number. The negative number shows that it is a deceleration, right? So it's deceleration. Now, the last part, what is this last part all about? The further distance covered before the car stops. So it is the second part of the journey. Second part of the journey is a continuation from the first part. The initial velocity for the final velocity for the first part of the journey is the initial velocity for the second part of the journey. Is this okay? The final velocity for the first part of the journey. Now, since you are going to continue the journey, this final velocity here becomes the initial velocity for the first part, for the second part of the journey. Is this okay or not? Is this okay?
Yes, yes.
Yes, the second part of the journey, the initial velocity is 10. Then they say further distance. How much is the further distance? That means you want to calculate the distance before the car stops. Car stop means the final velocity is 0. Okay, and the deceleration, although it is not mentioned in the second part of the journey, but we know that it is a continuation of the first part of the journey. So the deceleration is known. The deceleration is actually known. Is this okay or not? So now,
Yes, sir.
if I ask you which one of these physical quantities is given and which one they ask you to find. You look at this diagram here, the second part of the journey.
They given final and initial.
Final is 0. Initial is 10 because it's a continuation from the previous part.
Then they have given us the acceleration, which is -5.
Acceleration is -5 because it is a continuation from the previous part. So it's -5.
So
And
they
what
want us to find the displacement.
Okay, correct. This is what they want us to find, right? This is what they want us to find.
Yeah. So we will
Okay.
be using the third one still. Yeah.
Correct. It's the third one, right? So you copy down the third equation, substitute in the values, final velocity 0, initial velocity 10, then the deceleration is -5, right? Solving this linear equation, you have the displacement is 10 meters. So you will travel another 10 meters, further 10 meters before coming to stop. Okay. Any question on this equation of motion? So now you're familiar with the equation.